Well, we have learned about the transformations earlier in our module of the rigid motion transformation, and we learned that the three transformations, the translation, rotation, and reflection, those three transformations are called the rigid motion transformation because we do maintain the similarity and congruency in each one of these transformations. And this simply means that any geometric figure, when it goes through these transformations, the size or shape of that figure is not altered, right? And we also learned that when we apply dilation on any geometric figure, we do maintain similarity, but we lose congruency. And in the case of these two transformations, stretching a geometric figure either horizontally or vertically, meaning we are losing similarity and congruency in each one of those cases. Okay, now the purpose in this tutorial is that how do you actually account for change in the coordinates of any point on these objects when we send those geometric figures through one of these transformations. Okay, so let's discuss about that, and we will focus on translation first. So let me take a small rectangle here, all right, and on this object we apply some translation. We apply that it is moved a units to the right and then it is moved b units in the vertical direction, right? Now this means that this object that we have, it simply moves a combination of a and b units from its current position to its new location. So the question is this: if you were to take any point, let's say this is my vertex P, having coordinates x and y, what will be the value of the coordinates? Let's say it is P prime now because it is at a new location and it has new coordinates x prime, y prime. What will be those coordinates in relation to the old coordinate values? Okay, so the method is very simple. What we do is we write our old coordinates in the fashion x, y, in the ordered pair fashion, the x first, y second, and then we write our translation in the exact same sequence: x value translation first and y value translation next. And then you add x to x and y to y, meaning you add the x values and that becomes x plus a. That becomes your x prime, right? And then you add y value to the y value, meaning you add y coordinates with the y translation, and then you get your new y coordinate to be y plus b. So this is your y prime. So this is how you obtain your new coordinate values after you have gone through a translation of a units and b units respectively in horizontal and vertical direction. Okay, so that was very easy. Let's talk about rotation next. So to help explain rotation, we have this triangle. Let's say it is PQR, okay, and the point P has coordinates x, y. Our objective is that what will be the change in the value of these coordinates after a rotation of 90 degree, and what will be that change if I give one more rotation of 90 degree. Meaning by the time this triangle PQR reaches the third quadrant, I have gone through a transformation of 180 degree. So let's name these vertices. This becomes my P prime, correct? X prime and y prime. And then you have this vertex here, P double prime with x double prime and y double prime. Okay. My real objective is to understand what will be the change in values of these coordinates after a rotation of 90 degree and after another rotation of 90 degree. Okay. And the method is very simple. After a rotation of 90 degree, the x prime, which is the new coordinate, will be equal to the y value of the old coordinates and negative of that. Okay. And the value of the y coordinate equal to x, which is this value right here, right? So you see that whatever was the value of y coordinate, we reverse the sign on that, and that becomes your x value after a rotation of 90 degree. And whatever was the value of your x coordinate, that becomes the value of your y coordinate after this rotation of 90 degree, right? So keeping the same logic in mind, when you apply this translation, one more translation of 90 degree, then I can say that the new coordinate, which will be x double prime in this case, right? Because we are right here now, it will be equal to what? Apply this translation one more time and you will find that x double prime is equal to negative x and y double prime is equal to negative y. So now I will leave it up to you that how did I arrive at this conclusion that x double prime y double prime is equal to negative x negative y, right? So I am assuming certain things, that I am assuming that the values of these two coordinates x double prime and y double prime, I want to calculate that value after having gone through a rotation of 180 degree and with respect to its original condition right here. So with that, we have covered our rotation, the change in coordinates after rotation. Now let's talk about the reflection. Now in reflection, we remember that if there is an object A, B, C, and if you were to reflect it along the y-axis, meaning y-axis is my mirror line, then you get your new triangle to be as A prime, B prime, and C prime. And you know that the fundamental property in reflection is that if you take any point on this original object, and if you measure the distance of that point from the mirror line, then that distance will be identical to the distance of the reflected point from the mirror line, right? And because of this property, let's say we want to define what will be the change in value of coordinates if the point C had coordinates x and y. What will be the coordinates of the reflected point with reference to the original points, right? Now in reflection, the only thing you have to keep in mind is that what is the axis of your reflection. In this case, I'm saying that it is my y-axis that is being used for reflection. That means x is equal to 0 on the y-axis, right? In that case, the values of my x coordinate after reflection will be equal to negative x, and the value of my y coordinate will remain unchanged. And that is the value of my x and y coordinates when I'm reflecting something along y-axis. This is crucial for us to keep this thing in mind. And keeping that in mind, what will be the case if you are reflecting an object along x-axis? That simply means that your coordinate of the mirror line is equal to y is equal to 0, right? And the new coordinates x prime and y prime, it will be equal to, when you're reflecting something along the x-axis, your x coordinate remains unchanged, meaning the new value of x prime will be equal to the x value as it was before reflection, and the y coordinate will change. Now y prime will be equal to negative value of whatever the value was before. This will be in alignment with the principles of reflection, because reflection makes sure that the distances are the same. It's only the change in sign values, and that is crucial to understand if the reflection axis is x-axis or if the reflection axis is y-axis. Accordingly, you will change the sign of only one of those coordinates. The other coordinate remains the same. So we covered the change in coordinates for the rigid motion transformations. Let's talk about what happens in the change in coordinates when we do the dilation on any object. So what is really dilation? Dilation is either expanding or compressing an object from its current size. Okay, and in dilation, we come across one term. It is called dilation factor. And in short, you can call it as D. When D is equal to or greater than equal to, I would say 1, then we say that the object is going through an expansion. And if D is less than 1, then we say that the object is going to go through compression. Okay. So let's do this. Let's take a dilation factor equal to 1.5. That means I would like to expand this triangle ABC that we have with us. Okay. So let's select this object and let's increase the size of this object by 150%. So there you go. This is precisely 150%. Okay. But our real purpose is that, having explained dilation, if you were to take the point A, which was before expansion, what will be the value of that point A prime that will be after expansion, right? In this case, every point on this shape has gone through a dilation of 1.5. And that gives us a very simple clue that means the x value, which is after the dilation, should be equal to D times the x value, which was before the translation, right? And y prime will follow the same rule, that it will be equal to D times y. And this is exactly my new coordinate values, that is after the expansion, right? After a dilation of 1.5. So keeping the same thought in mind, let's talk about horizontal stretch as well. Okay, in this case, I am drawing a rectangle. All right. In this case, let's say that this rectangle take one vertex only, and this is the vertex P having coordinates x, y. Okay. Now, I want to expand this rectangle only in one direction. Let's say that direction happens to be horizontal only. Okay. So what really you notice is that this point that was originally here, P, x, y, this point now becomes as P, x prime and y prime. In this case, since you were expanding this rectangle only in one direction, right, it will be very simple for you to understand that since it has gone a transformation through x-axis only, so the new value will be d times x, where d is the expansion factor or the dilation factor along the x-axis. And the new value of the y coordinate will be exactly the same as it was before, because you don't see any change in the value of y. If this was my xy coordinate plane, you notice that this distance hasn't changed, right? That means there is no change in the value of the y coordinates. And just along the same line, let's say if you draw a rectangle, and if you make that rectangle go through a vertical transformation, meaning a vertical stretch, then you could conclude that the change in the value of this coordinates x prime, y prime after a vertical stretch will be something like this, that there won't be any change in x value, but the y value will go through a transformation equivalent to the old value of times the transformation factor, right? But this is as simple as to understand how the dilation impacts your coordinates. If it is a combined dilation, meaning just the way we discussed that if the dilation is going through all directions, both the vertical and the horizontal axis, then you multiply the old coordinates with the dilation factor. If the dilation happens to be only in singular axis, then you multiply the dilation factor only along that axis along which the change is happening, just the way we saw about the horizontal and the vertical stretch. So with that, we will take a pause here, and in our next tutorial, we'll talk about how transformations can be linked to reflexive transformations. Okay.